about kinematics of particle. We have examples under the displacements of vector. Let the positions vector of particle P given at time t seconds by the position vector rt equal to 2ti plus t square minus 1 plus 3k. Find Roman figure 1, the position vector at P at t is equal to 2 seconds. 2. The displacement of P at the end of 2 seconds. If we are to explain this, we have now the position of vector of a particle at time t is rt, meaning that the value of rt, you just put the value of t into it. Now we proceed. You now say at time is 2 seconds. So which we are be given the rt to be this, and you just substitute the value of r, you just substitute the value of 2 to any way that you see t. It gives you 2. You open a bracket, you put the 2 high plus 2 square minus 1 j plus 3k, which is equal to 4i plus 4 minus 1, meaning that 2 square is 4, j plus 3k, which the answer is 4i plus 3j plus 3k. That is the value for the first question, who said find the position of vector at P at t is 2 seconds. So the answer for that is 4i plus 3j plus 3k. We proceed to find the second value, the displacement of P at the end of 2 seconds. The formula for after 2 seconds is the value at when t is equal to 2 minus when t is equal to 0. So which the reposition vector given is 2ti plus t square minus t minus 1j plus 3k. So at t is equal to 0, we substitute the value of 0 into it. You get minus j plus 3k. And the formula for the after 2 seconds is when the position vector at time 2 minus time 0. So it means at time 2 the value is 4i plus 3j plus 3k minus j plus 3k. You try to solve, you collect the like times. You only have one high, that's why we have 4 high. 3j plus j and plus 3k, so the final value give us 4i plus 4j. That is how to find the solution for displacement of P at end of the 2 seconds. Under the displacement, we want to explain the example 2. The example 2 of, he said the path of a particle is given by rt equal to rt square minus ti plus t square plus t j. A, when is the particle at position is 0, 2, 0. B, does the particle return to its position at t equal to 0 for any positive time? This, the first thing you need to know is at point is 0, 2, 0, where s is equal to 0, because this is 3D position. At s equal to 0, y is equal to 2, and z is equal to 0. So the real equation for position vector is xi plus yj plus zk. So rt now given from the question, t square minus ti plus t square plus t j, which we all know that s is equal to 0, y also is equal to 0. You now equate it to have t square minus t is equal to 0 and t square plus t is equal to 2. In that t square minus t equal to 0 and t square plus equal to 2, you just equate. This will give you t is common and t minus 1. So, and t square, by the time you equate this, the first one you equate, you have t is equal to 0 or t minus 1 equal to 0. So t is equal to 0 and t is equal to 1. So for equation 2, by the time you equate t square plus t minus 2 by a quadratic equation, we end up by having t plus 2, t minus 1 is equal to 0. T plus 2 equal to 0 or t minus 1 equal to 0. So t equal to minus 2 or t equal to 1. If you're able to observe, when t equal to 1 second, satisfy the both equation. When t is equal to 1, the particle is at the point of 0 to 0. The b part, which is the last of the two. So the RT equal to, now when t equal to 0, you put the value of 0 into t, is 0 square minus 0 I plus 0 square plus 0 j. So r at time 0 equal to 0 j plus 0 I plus 0 j. Meaning that s is equal to 0 and y is equal to 0. You will now equate this t square minus t to be 0, t square plus t to be 0. By the time you do that, you discover that t is equal to 0 or t minus 1 equal to 0. And for this equation 2, t is equal to 0 or t plus 1 equal to 0. So t is equal to 0 or t is equal to 1, t is equal to 0 or t is equal to minus 1. The both equations are both satisfied at t equal to 0. Therefore, the particle does not return. Don't forget to subscribe to this YouTube channel for more of these solutions, for more of this explanation. Just click subscribe. You see the next. Thanks for this lecture.